This video is going to be about the conservation of linear momentum in the specific example of an inelastic collision. An inelastic collision is a collision where the objects remain connected after the collision. Momentum in an inelastic collision is conserved. However, unlike an elastic collision, kinetic energy is not conserved in an inelastic collision. However, as always, total energy is conserved. Let's look at a specific example of an inelastic collision. If I take two railroad cars, each having a mass of 1,000 kilograms, and I'll give the car on the left an initial velocity of 10 meters per second, and we'll give the car on the right an initial velocity of 0, meaning that it's currently at rest. When the cars collide in an inelastic collision, the train cars are going to lock together, and now they're going to move as one mass. So I'm going to have two 1,000 kilogram train cars attached after the collision, moving at the same final velocity v. And what we'll do next is we'll try to figure out what that velocity is going to be. So I know the momentum before the collision is going to be the same as the momentum after the collision. So the mass of the car on the right times its initial velocity plus the mass of the car on the left times its initial velocity gives us the momentum before the collision of the system, and the sum of the momentums after the collision should be equal to the momentum before the collision. Okay, I'm going to do my substitution. The car on the left has a mass of 1,000 kilograms. Oh, before I get started, I wanted to modify this equation so that since they're moving as one velocity, I can factor out the velocity and just take the sum of the masses after the collision. So the final velocity v1 and v2 are the same because both objects are moving together. Now I can do my substitution. 1,000 kilograms times 10 meters per second plus 1,000 kilograms times 0 meters per second for the other car should equal our final velocity plus the sum of the masses of the two cars. I solve for v and I get 10,000 divided by, 2,000 is equal to 5 meters per second. So at the end, both cars are moving with the same velocity because they're attached to one another at 5 meters per second. That's the end.